slide by slide. But the idea behind arrays is that you have a list. And each item in the list is consecutively numbered by its index value. So that's element 0, that's element 1, that's element 2, that's element 3, and that's element 4. Now in this language, unlike Python, you can't just start appending to the end of arrays. There are data structures you can do that with that are equivalent to Python lists, but you can't. Once you declare an array in Java, that's its size. If you want to add items to the end of it, you have to allocate a new array and then copy everything from the old one to the new one. It's like you have an apartment complex and it's full. If you want to put more people in it, you tear down the apartment complex, move everybody into the new one. Really annoying, but that's what you got to do. So that is a reason why we will be happy to hit another kind of data structure that is flexible, that does expand and contract as you need it, as you remove items from it. So to declare an array, it's always a little bit in each language. Here's how we do it in Java. We give the data type, we give the square braces, and then we give the variable name. And if I'm not mistaken, you could put the square braces at the end as well, since an older version of Java did that. But this is the accepted way to do it. And you also declare it that way if you're writing a procedure, a method that takes an array as a list. Not as a list. Takes an array as a parameter so that you can pass in an array as an argument. Declare it the same way. Now when you declare it, it's not actually allocated yet. It's empty. You can't start using it yet. Notice that we haven't specified how many items are in our array. We haven't said that we have 10 phone numbers or whatever. So later on, you got to actually allocate it. And you create it just like you do any other object. An array in Java is treated as an object, weirdly enough, rather than just a pure thing in memory like C++ array. So you use the new keyword to construct your array, and you specify a list size. Now in C++, you have to keep careful track of your list size because you can't necessarily just query the array and find out how long it is. But just like Python, you can take the length of the array. In this language, you can call .length, and it'll give it to you. So you don't have to keep track of that size of list thing. On the other hand, it's not a bad thing to have hanging around. If you want to define it as a constant or something so that you can access it easily, that's cool. And I'll show you why. If you're doing this for int I is equal to 0, I being the index value, I is less than array, my array dot length, I plus plus, and you had that as a constant, maybe it'd be faster to, to type it, but it's not going to make it run any faster, because dot length is just a property of it. It's not a method, so it's not like it actually takes any extra time to access it than if you had just defined a constant. Lost. So an array is a variable. It must be declared, and then you can allocate it. So that's the declaration, and then next comes along the allocation, and you can do both of those at the same. So an array initializer. You can specify what values you would like to be in the array. If you do that, it allocates itself to the number of items that you list in the initializer. Here we have 3 items in the list, so it's going to declare the array to be 3 items, no more, no less. That's a little bit different than C++. I'll just mention that and then not go on. So an array is an object with the elements as instance variables. Weird way to think about it, but it is. And each instance variable gets a default value. Just like if you create a class. If you create a class and you have an integer variable, then it gets set to 0 when the constructor is called. unless you give it a default value otherwise in its declaration. For a floating point, it's also 0. For Boolean, it's false because a false is like a 0. And for a reference, like a string or another object type, it's null. So, what are the default values below? Well, here's we have 1,000 0.0s. Here we have 50 nulls. Can't use those strings. All we have are nulls. So let's go ahead and play with Netflix. Netflix? What in the world am I talking about? Yeah, let's do some Netflix. All right, we're going to do some NetBeans. So I'm going to create an array of strings, but I'm not going to put anything into it. It's a bit big, but... Alrighty. So, string, but it's an array, colors. Alright, let's print out our colors. There's two loops that are useful for printing out arrays. I think I mentioned this in the video. One is a iterated loop where you have an index counter, and the other is a for each loop. I know that we probably hit these in Python as well, where you used an index to go through the loop, or you just use the values. But let's do this. Let's do it this way. For int I is equal to 0, I is less than the length of the colors array. I++. And let's just print that value out. System.out.printf. I want to print the index value out, %d, and I want to print the color out, %s, and then a \n. Comma, I, because I'm curious about the index number. And I seem to have made a mistake here. I'm not sure why that's underlined. Oh, it's warning me it hasn't been initialized. I wonder if it's even going to compile. There's a chance it won't. Let's find out. My example here of what can go wrong when you use an array may be for not, but okay. So, colors subscript I. All right, one or more projects were compiled to theirs. Java is smart enough to try to refuse us to. Well, yeah, okay. So string colors is equal to new string out to 10. We want 10 different colors in our list. But it's not 10 strings, it's 10 null references. This makes it look like it's creating 10 strings, but it's really not. It's just creating room for 10 string references. Kind of a different concept. So when we run it, what does our for list print out? Prints out all nulls. Well, let's start filling it in. Let's give ourselves a value. Colors subscript 0 is equal to red. Colors subscript 1 is equal to blue. Usually I do RGB, so green should have been next. Colors subscript 2 is equal to green. And just like everything else in computers, we use zero-based indexing, so the first item is a 1, the first item is 0, the second item is 1, the third item is 2. Well, let's print it out again. Just grab those, copy that print statement, and paste it to save time. And give that a go. Now when I run it, it shows red, blue, green, and then a whole bunch of nulls. What if I didn't want to display nulls? What could I do to fix that? That's not a rhetorical question. I'm actually going to ask y'all. So what I've done is I've created an array. It's 10 references. They all defaulted to null, so that when I printed it printed out 10 nulls. So I decided I'm going to fill in some of the values in that array. And then I printed it out again, and it shows those values, but the for loop is also still printing nulls. What could I do to stop those nulls from being printed? And there's two answers I can think of.
If has value, print value.
If value not equal to null, print it. So we could do that. That'd be one way to fix it. I'm going to copy this for loop a couple more times so that I can try both of those out. So if colors I not equal to null, print it out. That's an absolutely fine way of doing it. It's not the only way. All right, it printed red, blue, and green. Very good. The other way would be to know how many items we have filled in. And if I had a printer, I guess there is a printer back there. Let's see if I can print this out for y'all. Came in. Nope. Okay, maybe not. All right, guys. If you just came in, these are the lines you need. Take a picture on your camera so that you can look at it and type it in, okay? Or if you're just going to watch along, that's also okay. Okay. That's one way. The other way is if we had kept track of how many, right? We could modify our for loop. If we put in I is equal to 0, I is less than 3, that would work. But how do we know that 3 items have been entered? Well, what if we did this? What if instead of 0, 1, and 2, we did this? Int items is equal to 0. And then instead of 0 there, we did items plus plus. And then again, we did items plus plus. And then the third time, we did items plus plus. Now, by the time we get here, the number of items will be 3. 0, 1, 2, 3. So if we do I starts at 0, I is less than 3, it'll only print out the values we want. So that would also work. I'm going to copy this for loop and just paste it in one more time with that change. So instead of colors.length, I'm just going to make it less than items. So now the first line, the first 3 output are going to be correct. Then it's going to go, you know, red, blue, and green. We ought to be sticking something between these print statements, right, so that we can make sense out of the whole thing. Okay, I'm going to do that. System.out.println. How about a couple of character turns? There, just like that. I'm just going to stick that after every for loop. You don't have to do that if you don't want to. All right, that's better. So that was where we use the item number of items, to limit our printing. So what this problem is known as is a partially filled array. And sometimes you can't use nulls as a way to track, because what if these were integers? What if they were daily sales? Well, 0 is a valid daily sale, right? So we couldn't just do if sale subscript x equals 0, don't print it, because 0 is a valid sale. So yeah, you could get around that and get squirrely and try to initialize a whole array with values like -99999 and then say if the item is equal to -99999, then skip it. But the other thing, probably the better thing to do is to keep track of how many items are in it and only process. So that's how you handle partially filled arrays. And I'm going to put that as a comment in the code. Or here. I guess I'll wind up copying my source code over there anyway, so why not here? So for the one that went out to items, I'm going to add a comment. This is considered the usual best way of handling partially filled arrays. You just keep track of how many items are there. When do you wind up with partially filled arrays? When you don't know how much data there's going to be, right? A test score grading program. When you're writing the program, you don't know how many items, how many tests are going to be. So you have two choices. One is you could ask the professor, you could ask the teacher, how many test scores will we be grading? The other thing you could do is enter test grade number 2 or -1 to stop, right? That kind of thing. And if you're doing it that way, you don't know how many test grades they've entered unless you keep track of it. So you have a partially filled array because you can't allocate your array to the exact size. You can if you know in advance, but if you don't know in advance, you have to allocate your array to the maximum value. If you're not sure if they're going to enter 10 numbers or 100 numbers or 1,000, you've got to allocate 1,000. Seems kind of wasteful. Otherwise, you have to come up with some really, I won't say it's really kooky stuff, but since arrays are not dynamic, you're kind of stuck with the number that you allocate them at. So what if we have some numbers and we want to calculate the minimum and the maximum? Did the video cover that? Getting the minimum and the max? Okay, so we don't have to do that. What about parallel arrays? Did the video do parallel arrays, like when you have days of the week versus temperatures for that day? Now I know that we...
I think it was just one-dimensional.
Okay. All right. So we're going to talk about parallel arrays now, which are actually still one-dimensional arrays. And the term's going to be familiar because we covered them in my 1113 class, if you took that with me, or C++. Parallel arrays are 2 or more arrays of equal length where the elements are linked by their index number. So, you know, good old, shouldn't do that, it's going to take forever to load up Excel. But you're used to the idea, really. So, I'm going to kind of flip my idea here, but if you have Joe here, and Joe's last name is Bob, and he really likes apples, and he earns $90 a week. And so then we have Sue Smith, who really likes oranges, and she earns $85 a week. And then we have Becky Williams, who really loves grapes, and who earns $95 a week. So we could put names on these columns. You know, this is first name, this is last name, this is fruit, and this is salary. Whatever. We have 4 arrays here, linked by their index values. Pretend that's a 0 and that's a 1 and a 2, right? So the first element in each array is for Joe Bob. The second element for each array is for Sue Smith. And the third element in each array is for Becky Williams. So we have 3 arrays. And then you go, well, why don't we make a 2-dimensional array? Because we could have different types here. We might have numeric typed ints here, and floats here, and strings here, and something else. Now I'm going to say the next thing, which would be a great way to handle it, but we could also have a single dimensional array of objects, and each object tell all 4 of these. But we're not going to do that now. That's a different concept. That's an array of objects, and right now we're just talking about simple arrays. So in order to implement this in our code, we would need 4 arrays. 3 of them would be strings, and 1 of them would be a numeric type. Let's shorten that, though, for our example. That'd be okay, actually. But I'm just going to hard code these first ones. String, like that, fname is equal to, and let's put a couple names in there. So between the curly braces and the semicolon, we have Joe, Sue, and Mary. Then we have string, square braces, L name is equal to Bob, or Roberts, I'm trying to make these sound like last names. Susan Williams, and Mary, what's a good last name? I don't know. Thompson, yeah. All right, so there we go. And then let's make some salaries or some kind of numbers, maybe some ages. The list declaration is different than it is in Python. We don't use square braces to initialize our list. For one thing, these aren't lists, but anyways. So Joe Roberts is 30 years old, Sue Williams is 45, and Mary Thompson is 25. And I've made a mistake. Because he's not supposed to be strings. Right. Answer floats. Whatever. Ints. Whole numbers only for age. However, people like to measure their weights in doubles. Okay, so if we wanted to print this stuff out, we know, and don't necessarily type this, but if we printed out fname 0, and we printed out lname 0, and then we printed out age 0, it would print out Joe Roberts, who is 30. And then if we changed all those to 1s, it would print out Sue Williams, who is 45. And if we printed out the rest of them, it would be Mary Thompson, who is 25. Let's go ahead and make a for loop that'll do that. We need an index counter. You can't use a for each loop to step through a parallel array. Well, no, I should never say can't, but it doesn't lend itself to it at all. So for int, I is equal to 0, I is less than the length. Now hopefully all three of these arrays are of the same length, because if there are different lengths, then it's no longer a parallel array. So I'm just going to assume that the length of any of them will work. Right? Because if this one had 4 names in it, you know, Roberts, Williams, Thompson, and, you know, Smith, then who would be Smith, right? There's no Smith. So they have to be of the same length. So instead of hard coding 3, I'm going to do fname.length. I++. All right, I feel like printing these things out. System.out.printf %10s, %10s, %, I don't know, an age will never be larger than 3 numbers, so 4D, \n. End quote, comma, and I'm going to the next line because my font's larger than yours. Fname, subscript I, comma, lname, subscript I, comma, age, subscript I. And if we wanted to make a nice pretty header, we could do that. We could print out something above it. System.out.printf %10s, %10s, %4s. There's method to that madness. And the first column is what? First name. Is that 10 wide? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's a little. I'm just going to call it first. End quote, comma, begin quote, last, end quote, comma, begin quote, age. Then if I wanted to, I could print out a series of dashes. I'm also going to stick a \n in the front of it. I guess I could do that on its own column. Line, system.out.println, just like that, just so that it appears on a blank line. Okay, so when I run it, if I don't have any typos, it should print out our little table, our little parallel arrays. Joe, Sue, Mary, Roberts, William, Thompson, and those are the ages. Now notice that it's it's right justifying our string. That may be cool, you might like it, but on the other hand, you might want this stuff left justified. Have we talked enough or at all about using the printf statement and how to control whether things go on the left line or the right line? The left side or the right side? Does this line make any sense at all, %10s?
Isn't that 10 spaces?
Yeah, it's 10 spaces wide, and it's supposed to be for a string. This is 4 spaces wide, and it's also supposed to be for a string because I passed in age as a string. Down here, the age array contains ints, so I use %4d.
And D is in.
D is in decimal. I wish it was double, right, but it's not, decimal. If this is a floating point number, like a double, I would do %4f. So for printf, %s is equal to string, %f is for floats or doubles, %d is for long, ints or long. You specify the width after the % sign, and if you want to specify the number of decimal points, or the number of places after the decimal point for an f, you can do that. So examples would be %10s, %5d, %6.2f. That would be, I wanted to fill it 6 spaces wide, but I want 2 of those spaces to be places after a decimal point. So really that gives you 6, but you have to take away 2 for the last 2 and then 1 more for the decimal point. You have 3 numbers in front of the decimal and then a point and 2 more. So that last one is 6 spaces with 2 places after a decimal point. What if we wanted to modify this so that it asks for their weight? Whatever. We would need another array for weight. I'm going to come up here and declare the array for weight right up here along with the other ones. And people like, to measure their weights in fractions. I'm 137.25 pounds. Okay, so double square brace weight is equal to new double, and I could just hard code it to 3, or I could hard code it, not hard code it. I could use fname.len. I'm going to do that just to guarantee that it's the same length as the, because I want them all to be parallel arrays, they all have to be of the same length. That's the only reason why I did that. If you were going to make it to where people could enter the first name, the last name, and the age as well as the weight, which is a more common thing, right? Then you would not use initializer list. You would define a constant and say, number of items is 3, or number of items is 10, or something like that. And that'd be fine. It'd be fine. It's just in this case, I don't really like leaving it like that, but I'm gonna. Okay, so we want to let them enter their weights. So here's what we're going to do, and I'm going to put this above our little table here. I don't want to get too confusing about where I'm putting this, but underneath our 4 parallel array declarations, let's just print a blank line because it looks nice. System.out.println. Now we need a for loop to step through it. The for loop is going to look a lot like this one. For int I is equal to 0, I is less than fname.length. You know what I should do? I should do this. Int number or array length equals fname.length, right? Something like that would have been better. Then I could do int I is equal to 0, I is less than array underscore length. Either way is fine. I'm not going to go back and modify the other one. So then we need to print a message. Please enter the weight for Joe Roberts, and then give them an input. And do I have a scanner? No, so I got to declare my scanner. I'm going to scroll up to the top underneath the main declaration, put my scanner there. Doesn't know what a scanner is, so I'm going to add the import for it. Add import for java.util.scanner. All right, so I got that up there. I'm going to scroll back down to where I was underneath the 4 parallel array declarations. Okay, so print out the question. System.out.println. Enter the weight for plus, then the first name, fname at position I, plus a space, oh come on, tooltip, go away, plus a space, plus lname, subscript I. So double value or whatever is equal to sc.next double, and let's put it in the array. Weight at subscript I is equal to the value. I'm going to add a comment here because we're getting a lot of code in here. Get the weight for the people in our parallel arrays and store the weight in the 4th parallel array called weight. Oh, that makes sense. I'm going to remove the word 4th because, you know, we never know how many parallel arrays we might wind up with. All right, so we've got this information at this point, but we're going to have to modify our print loop in order to print out the weight as well as the age and the first name and the last. So where am I going to modify? What am I going to change in order to get that to work? What line number on my screen? There's probably more than one line. Am I going to have to modify in order to get it to print out weights as well as first name, last name, and ages? Yeah, 86 would be a good one. How wide are we going to make the weight column? Well, let's assume that they're not going to weigh more than 999 pounds. So 999 point, 2 decimal places, 99, and so that's 6 wide. So %6.2f. That's our formatting string for the last value. And let's fill it in with a word. W-E-I-G-H-T. Okay, what do you know? That's also 6, so that works out nicely. Then down here, I'm going to need to do the same thing. That column's also going to be, okay, this was really dumb. What's wrong with doing %6.2f there? What am I printing out in that column? A string, so that just needs to be %6s. But down here, when I'm actually printing data, it's going to have to be %6.2f. So that's my formatting string. It has to have a matching value in the argument list. So now that I've changed that, I need to do weight subscript I. All right, I'm going to run it and see what happens. All right, another wait for Joe Roberts, 200. Sue Williams, 190. Mary Thompson, 210. All right, and there we go. Oh, and my little beef about the left versus right justification. These strings are right justified. So I'm going to put minus signs in front of the width specifiers, which causes them to be left justified instead. So I'm going to run it again to see what happens if I enter like 1 digit, 2 digits, and 3, and see how it left justifies or right justifies the floating point column. So let's see. Joe is 5 pounds. Sue is 11, and Mary is 222.5. All right. These are also right justified, but for numbers they look good, right? At least in my mind. I like the numbers to be, I keep saying left justified when I mean right. These are pushed against the right side, so these are right justified. That looks good to me. I would like for the strings to be left justified though, so I need to go and modify the format specifiers. Put a minus sign between the percent indicator and the width field for those two strings. I also need to do it up here so that the first and the last appear in the right place. Be kind of nice if they were, centered and stuff like that. You can spend a whole bunch of time formatting tables to look pretty. If you want to do that, that's fine. I'm not going to go to that much trouble because there's no format specifier that says center this data within 10 characters or whatever. Alrighty, so Joe is 1, Sue is 11, and Mary Thompson weighs 111.24. Okay, I like my little table now. It's a parallel table. What is something that we could do with that data if we just wanted to make up further examples of processing arrays?
Calculate BMI.
Pardon me?
Calculate BMI.
Yeah, we could. You're right. Well, we don't have a height. Yeah. That'd be a cool little assignment to tack on, though. I'm sure that my other classes have done BMI, but this one hasn't. Let's add a height column. So come up here, add one more column. I would also make it double for height. You go ahead and type. Don't wait for me to type it. Although I'm gonna, obviously. Double height is equal to new double fname dot length. And we know that we're going to want BMI. What is BMI? It stands for body mass index. It's a calculation you can make for weight versus height. And for specific people, it's not a real indicator of health, although they'll say if your BMI is such and such, you're overweight. But a football player with a lot of muscle will always show up as overweight on things like these. So, but anyways, BMI, it's also a floating point value, is equal to double fname dot length. The idea that I'm going with this is that we're going to set it up, and then as homework, I'm going to ask you all to calculate the BMI and add it to the table. Okay, let's go ahead and make some homework notes. The following code asks for height, but weight, but not height. So add code that will prompt for each person's height in inches. Then calculate each person's BMI according to the following formula. BMI is equal to 703 times the weight in pounds divided by the number of inches times the number of inches. Storing these values in the BMI array. So the following code asks for the weight but not height. Add code that will prompt for each person's height in inches and store in the height array. Then calculate their BMI according to the store that in the BMI array. Modify the table printing code to display the height and the BMI as columns as well. That's what we already have. That makes sense? Hope so. I saw a couple nodding heads. Did you nod, or is there something I need to explain?
Okay, then
Okay, cool. I like this one because what I usually do is I make, rainfall or temperature. I think this is more interesting.
I remember doing something like this in the.
Well, I know we
Java.
calculated BMIs in an earlier class, so it's a familiar formula. Why do I use BMI? Because everybody knows what height and weight means, and if I do physics problems or chemistry problems or whatever, it doesn't resonate quite as well. Okay, so going back to here, the length value is a property unlike strings. So if you declare an array like this, int vals is equal to new int 10. Vals.length is a property, an instance member, that contains 10. If you declare a string like this, string s is equal to Bob, then when you want the length of it, in Python you do that, but nope, no Python. S.length, parentheses in parentheses, is a method that returns 3. Subtle difference. But when you're typing things along, you're probably going to add parentheses to .length by accident if you've been using .length a lot with your array, with your strings. So somebody came up with some cute little mnemonic that you're supposed to remember when you put the parentheses and when not. Just remember. Oh, here it is. ANSI. Arrays no, strings yes. Okay. I just trust that you can remember it. Array length property and partially filled arrays. That's what we mentioned. If we're letting them enter data, but we give them the option to bail out early, you better have kept track of how many items that they've entered. Otherwise, you're going to wind up doing tricks like if item not equals null. And although that's a useful technique to have tucked away, if you're dealing with partially filled arrays, it's better just to keep track. Copying an array. Did the video do copying an array? Not seeing a lot of emphatic head nods. So here's how you copy an array. Say I have an array that looks like this. Int nums is equal to, and I declare, I put some numbers in it, whatever the numbers are, like that. I want to copy the nums array into a new array so that I can sort it while having my original data, or so I can add one to each value or something like that, named nums2. Here's what I do. Create and allocate a new array of the same length as the original. Then copy each element from the first array to the second array with a loop. We may as well put this in the code, so I'm going to copy that part out of the notes, paste it into the code. Give you all a second to type up because I know nobody was typing the notes. I wouldn't have. Alrighty. So, at least get that int nums business going, right? Don't have to type my notes, unless you like them. So there we go. How do I get the length of nums of the nums array so that I can allocate a new array of the same length? Same way we've talked about several other places. Right, right. So int nums2 is equal to new int, and I have to fill in a value here, so I'm just going to do nums length. So that's like step one, create and allocate a new array of the same length of the original. And then copy each element from the first array to the second one. Now after we do this, NetBeans is going to offer us a change. It's going to say, why'd you do it like that? That's moronic. There are better ways. Yeah, but you got to know this one conceptually. So we're going to do it. Alrighty, so for int I is my favorite index counter, is equal to 0. I is less than the length of the array, which is nums or nums2 dot length. I plus plus. Now what should I make in this line here? I want to copy the value that's in nums and stick it into the same place in nums2. What would be a good thing to do there? I want to copy them out of nums, put them into nums2, so what should I put on the left-hand side of the equal sign? Nums2 subscript I is equal to nums subscript I. Right, we're treating those like parallel arrays actually. What kind of warning are you giving me here? The array is only written to, never read from. Yeah. No surprise, Sherlock. Okay. Manual array copy. Yes, in fact, this is a manual array copy. I'm going to accept the suggestion just to see what they want to do with it. Replace with system.arrayCopy. All right, that works. It's nice to have that. There's another one as well. I'm going to show you another. I guess I'll put that one in as a comment. You don't have to type it, but just know that if it offers you that and you feel like it, that's what you're feeling, go ahead and do that. There's another way too. There's arrays.copy. I think I botched that one. Yeah, original. So nums2 is equal to nums.copy of, is that going to work? No. I don't want to spend too much time on this. Arrays.copy of the original and then the new length. I don't know why my brain has failed to click on what this is. So I'm going to right click on copy of and do show Java doc. That didn't work. Okay, fine. I'm going to Google up arrays.copy of. So, arrays.copy of is a method in that class copies a specified array, truncating or padding so that the copy has a specified length. So here you go. We could do it like that. We could have said, well, let's declare another one called nums3. Int nums3 is equal to arrays.copy of nums. Can we just do that? Can we leave off the length? Will it? Nope, it wants us to fill in the length. Nums out to nums.length. If you wanted some space at the end to add some new data, you could do that. Now what are you complaining about? The array is only written to, never read from. Okay, fine. I don't care. So that's 3 ways of doing it, right? You can use system.arrayCopy. I never remember that syntax. You can do arrays.copy of. I like that one. It's easier for me to remember despite the fact that I just had to Google it. Ignore that. Or you can do it by hand. If I was going to ask you how to do it on an exam, I'd want you to do it that way. Write a for or while loop that will copy array 1 into array 2. That's kind of exam question. We could print the arrays out to show that they're the same. Or we could sum them up or something. Let's sum up one of the arrays. Alrighty. We're going to do Python. X is equal to sum. No, we're not going to do Python. Instead, we're going to use a loop. We need a variable to contain the total. So double total is equal to 0. And now I want to add each value in the array. Now we've written this loop with the iterator, with the counter, the index counter, often enough that I want to use a for each loop. So for every int value that is in the nums array, I hope I haven't already used value as a parameter, a variable, total plus equals value. Now we could print out the total if we wanted to, or we could calculate the average. Let's do that. Let's calculate the average. But I'm going to want you to tell me what the line is. Double average is equal to, how do you calculate average? By the number of items in the array. And what's the number of items in the array?
Length.
Yeah, nums.length. So average is equal to total divided by nums.length. Then we could print that stuff out if we so cared. System.out.printf total of nums equals %f, comma, average equals %f \n, end quote, comma, total, comma, average. And I'm going to put a print line above that. Same reason I have been the whole time. System.out.println. I could just put a /n right there, right? Oh, that's the problem. Once you add some input statements, you have to enter that stuff every single time. Okay, so why did I make the total a double? Because it was all ends. I mean, it's obvious why I made the average a double, right? But why did I make the total a floating point number as well? It's okay if you don't know, but
Did you do it so that it would match?
please repeat.
Did you do it so that it would match each side? Like you wouldn't just have 52 and 2.66?
No, I didn't do it for any aesthetic reasons. I did it because, and I could have corrected it, but if you divide an integer by an integer in this language and in C++, but not Python, when you divide an int by an int, it rounds it down to an int. So nums.length is an int. If our total was also an int, then our average would be rounded down to an int. We might not want our average rounded down to an int, right? Because the average of 0 and 1 is supposed to be 0.5, not 0. So I always make my total, my accumulator, a floating point if the language differentiates between the two, unlike Python, so that I can do that division correctly.
Could you possibly initialize total as an int and then maybe like turn the value of average into a double?
Well, you can. Well, let's play with that. If that was an int, that's well and good, but average is going to be a double. I'm getting a complaint down here about this not matching that, but that's okay. But when I divide an int by an int, I'm going to get an int. The only way to fix that would be to cast this to a double. I could say, oh, convert total to a double before you do that division, please. And then it would work. If you like doing it that way better, that's fine. So, y'all know what casting is? It's kind of like doing the int parentheses, and I know we did casting in Java 1. You know, that takes whatever data that is and it converts it into that form, so that when we divided it by an integer, the result would be a float. It's not like it can figure out, oh, you're storing it into an average, it's okay for me to give you a float. We have to build a float on this side because all of this happens before it even tries to be copied over there. All right, so I want to write up that assignment. Which means I'm going to want to copy all this stuff.
Oh, we got through an A. We did.
So homework, use the code to, and then I'm going to take all my comments here.
Can I get a copy of that when you're done?
Yeah, this is actually going to be what I upload, but I mean, I'll put all these as notes.
Are you gonna upload the your code too?
Yes, I'm going to do the Java as well.
In case you mess up, you can code back up again.
Yeah. Okay. The reason I'm kind of formalizing it is because I also want to add one more thing to it, a couple more points to it. Additional things to do for the next homework. I'm breaking into 2 homework assignments. Let the user specify how many people to track. Then ask for first and last names as well as height and weight. Display the table. Also display the name of the person with the lowest BMI and the highest BMI. Right, so this is like, what homework assignment are we on? We are on so that's homework 4. Alrighty. So that's going to be homework 5, 4, and this is going to be homework 5. That makes sense. In our code, we hard-coded 3 names, but that's kind of silly. We want to ask them how many names do you want to track. They'll type in 5, and then we'll ask them for 5 pairs, you know, first name, last name, height, but whatever, for all 5 people. So that'll just be a couple more scans, right, to get that stuff. The declaration should be pretty easy. Tracking the lowest BMI and the highest BMI. If I did cover that in the video, should be not a big deal. If I didn't, then be sure to ask about it next week, because that's what the homework assignment's going to be. All right, is that all good? We're good with that. Okay. You can use an array to hold a bunch of objects, as well as just primitive data types like ints and floats. Now, honestly, we've been doing that already with arrays of strings. We only have like 5 minutes left. Don't know about having time to do this. Yeah, let's do this. Way up here, above the public class here, I'm going to do the horrible thing of putting another class inside the same file, which I shouldn't. This is going to be our usual class circle. It's going to have a radius. It's going to have a constructor, public circle, int radius, which sets this dot radius equal to the radius passed in. And it's going to have a toString method. So public string toString parentheses in parentheses open brace string s is equal to string.format. Let's try to make this look pretty. Parentheses circle with radius %d, end quote, comma, radius, or this dot radius. Okay, so that's our little class.
Is there a functional difference between writing this dot radius instead of radius and then hooking the toString?
No, no. There's no difference. The only time there's a difference is if there's a local variable like this one with a name that conflicts with the member variable. That's the only time you have to use this.
Okay.
So if I just called this int r, I could have said radius is equal to r without using the this reference. Why am I getting an error here? Missing return statement. Yeah, what do you know? You're right. Return s. All right, so up here at the top of my main, I'm going to create an array of circles and print them out. And we're going to concentrate more on this topic after a while. But circle, square braces, circs is equal to new circle, and I want 3 circles. And then circs subscript 0 is equal to new circle with a radius of 10. Circs subscript 1 is equal to a new, I should have just copied and pasted, circle with a radius of 15. And circs subscript 2 is equal to a new circle with a radius of 20. And let's print them out with a for each loop. For every circle, for circle C in the circs array, let's just print out system.out.println C. That will invoke the toString method. If I wanted to make it explicit, I could do c.toString, but we're experienced Java programmers. We know that if we try to print something and it needs to be converted to string, the toString method will work. So now when we run it, if we scroll to the top of the output, we should see 3 circles at the top of our output. There we go, 3 circles. So you get the idea. You can stick anything into an array, including objects. And once you get the objects, you can reference the members and the methods of it. You know, if you had, I could have printed out c.radius if radius was a public member, or c.getArea if getArea was a public method. All right, that's about enough, I think. Are there any questions? Let me make a Dropbox so that we can hustle our way out of here.